Hey everybody, in this video we are looking at Chapter 1, Section 5 in Algebra 2. We are working on Exercise 27, dealing with the volume of the box. This ends up being basically an open-topped box created by a rectangular sheet of metal or material. A rectangular piece of metal is 10 inches longer than it is wide. Squares with sides 2 inches long are cut from the four corners, and then the flaps are folded upward to form an open box. So I'm just going to kind of start sketching out more or less what that's going to look like. So you start off, if you are pretty good on the visual for this, if you really have a picture in your head, then you might want to fast forward through this part. Here is my rectangle. This side is going to be what I'm going to call length of X. And this side over here will be X plus 10 inches longer than it is wide. So X plus 10. Now, what they'll do to make this open topped box is we're going to essentially cut out it has to be a square, okay? Otherwise, like, this doesn't work, but you cut out a square from each corner, okay? And as we cut this square out, the part that's, left white in this picture is left behind. You're going to fold here, you're going to fold here, and fold here upward. And basically, the two red lines will come together, right? These two orange lines will come together. These two green lines will come together. And these two blue lines will come together. And you will have an open topped box, all right? So that's what's going to occur. And that open topped box will look something, like what I'm about to draw in the next picture. And it will be, I don't like when I mess that up, something like, this is not at all going to be like to scale based on the picture. I'm just pretend we have x-ray vision, right? Okay. And there you go. Well, something like that, okay? Now, the whatever, you get the gist, right? So now when we cut out that square from each corner, they said we're cutting out 2 inches by 2 inch squares. So I'm going to make them look pretty small, but they're going to be cut out. And again, the dimensions are 2 by 2. And then color coordinating a bit more, this blue part right here is going to be representative of this blue, more or less right here, that length, and over there, and back inside over there, if you could see that, right? So it's really coming from those pieces. And then in green, you will have this other length over here. Right there. And then the pinkish reddish ones, something like that. So what do I know? Well, I know that the height is definitely 2 inches. I know that this green line, okay, X was the whole entire thing, right? X was the length from there to there. So the green is going to be X minus 4 because we took away 2 2's. And then the blue over here. Now the purple, X plus 10 went from, all the way to all the way, but I cut out a bit. So X plus 10 minus 2 more became X plus 6. So those you have, you'll have your length, your width, and your height. So maybe I call that one length. And maybe we call this one the width. Doesn't really matter, okay? If the volume of the box, flaps folded upward to form an open box. If the volume of the box is 832 inches cubed, what were the original dimensions of the piece of metal? So I'm looking for the dimensions of the piece of metal, the original. And it's always good to write that down when you have a busier problem. So the dimensions were X by x plus 10. So we want to make sure when all is said and done that we figure out what those were originally, because that is our final answer, okay? So with those dimensions, let's go ahead and finish up the problem. So volume of a rectangular prism is length times width times height. The volume was given in the problem, and that was 832 inches cubed equals the length we called the blue one. So the length is x plus 6. The width is the green one, which was x minus 4. And the height was a constant value of 2. I'm going to divide both sides by 2. So that's going to be 416. You should not need a calculator. You should not need to do work on the side. What's half of 800? 400. And what's half of 32? 16. Okay? Guys, got to keep it light. I'm going to distribute x plus 6 times x minus 4. Xx is x squared. Minus 4x plus 6x is plus 2x and minus 24. This is a polynomial equation. You need to know what to do with the polynomial as soon as you see it. We want to get it equal to 0. So I'm going to subtract 416 from both sides. And that means we'll have 0 equals x squared plus 2x minus 400 and, well, negative minus something is basically adding, except your answer is negative. 416 and 4 is 420. 20 more is minus 440. Now, if the middle was not there at all, right? If there was no middle, that would mean my outer and inner were the same products and that one was positive and one was negative, and that's why they went away. When the middle number is like a 1 or a 2, that just means that the two numbers you would pick to split your middle with AC method are going to be relatively close to the square root of that number. I know that the square root of 400 is 20, so I want to be in the ballpark of 20, maybe bigger than 20, when I'm kind of jumping to this and want to factor pretty quickly. And if we look carefully and think about 440, 20 times 20 is 400. That means 20 times 22, think about it, is 440, and that also makes a 2 for the middle. So if you factor pretty quickly, that'll be x plus 22 and x minus 20. Then zero product property, we're going to set each part equal to 0. Then x equals negative 22, which is automatically extraneous. That's so silly. And then x equals 20, which does make sense. Winner, winner, chicken dinner. So 20 inches. And like we said, this one is an extraneous illogical solution. We cannot have a negative length. Now, did we answer the final question? No. Take that answer and let's go back up to the top. It wants to know what are the original dimensions. So they were 20 inches. Maybe I shouldn't do pink because it's going to be a little deceiving. 20 inches by x plus 10, so 30 inches. And there you have it. So that right there is your final answer. The original sheet that we started with to make our open topped box had dimensions of 20 by 30 inches. And then if you wanted to go back and check and see if your answer makes sense, by all means, you could go ahead and do that, or you could go to the next question, okay? So hopefully you found that to be helpful, useful, right? There you go, classic polynomial. But think smarter, not harder, okay? These are not big, scary numbers. This is not decimals or anything like that. These are round, whole numbers. They work out nicely. You just need to clean things up nicely and not make it look crazy, okay? Just so everything comes down to fundamentals, all right? Whether from geometry or algebra. That's it for now. Hopefully that you could find what you're looking for on the playlist in the description box, or the playlist that is on the screen. And I'm recording more from this problem set as you're probably watching this. We'll see. Adios.